Welcome to AI Builder Lab, where we build real-world AI applications together. In this video, I'll show you how I built an AI prompt optimizer using FastAPI and Gemini AI. By the end of this first part, we'll have a working backend that analyzes requests, connects to the AI service, and is ready for the front-end integration in part 2. Let's get started building it together today. Every successful software project starts with understanding the problem before writing the first line of code. For this project, I wanted to solve a challenge that many people face while using AI tools. Most users enter short or vague prompts and expect high-quality responses, but AI models can only work with the information they receive. Instead of building another chatbot, I wanted to build a tool that could evaluate prompt quality, identify missing information, provide practical suggestions, and generate an improved version automatically. To keep the project focused, I created a product requirements document outlining the project's goals, core features, technical stack, and expected workflow. Spending time on planning before development helped me avoid unnecessary complexity and gave me a clear roadmap for building the MVP step by step while keeping the architecture simple and scalable. Before creating the application, I initialized a dedicated GitHub repository for the project. I prefer starting every project with version control because it allows me to track progress from the very beginning instead of waiting until the application is finished. Every meaningful milestone becomes a commit. Make it easy to revisit previous versions if something breaks during development. This approach also creates a clean development history, which is useful when documenting the project later or collaborating with other developers. Since this project is intended to be open source, having a properly organized repository from day one was important. It also helps when creating a professional README, managing future updates, and showcasing the project on GitHub. With the repository ready, I was confident that every improvement would be recorded, allowing me to focus entirely on building the application without worrying about losing progress. After creating the repository, I organized the project into separate front-end and back-end directories. Keeping these applications independent creates a cleaner architecture, improves maintainability, and makes future development much easier. The front end will eventually handle the user interface, while the back end will manage business logic, AI communication, and data validation. I started with the front end by creating a new Next.js application. At this stage, my objective wasn't to build the interface immediately. Instead, I wanted to verify that the project structure was created correctly and that the development server was running without any issues. Establishing a stable foundation before implementing features helps reduce unnecessary debugging later. Once everything was working as expected, I created another Git commit. I like committing after every significant milestone because it creates clear checkpoints throughout development. If something goes wrong later, I can always return to a previous working state instead of searching through hundreds of changes. This simple habit has saved me countless hours while building software projects. With the front end initialized, I moved on to setting up the backend using FastAPI. Just like before, the first objective was establishing a clean project structure instead of implementing application logic immediately. I created the backend directory, initialized a Python virtual environment, and verified that everything was configured correctly before adding any dependencies. Taking time to validate the environment early helps prevent configuration issues that are much harder to diagnose later. Once the basic backend was running successfully, I committed the changes to GitHub. Making frequent commits is one of the simplest practices that improves productivity because every commit becomes a reliable checkpoint during development. It also creates a clear timeline showing how the project evolved from an empty repository into a complete AI application. With both front-end and back-end successfully visualized, I was ready to begin implementing the actual functionality. With the project structure ready, the next step was installing the libraries that would power the backend. I wanted to keep the dependency list minimal and include only what was required for the MVP. Fast API would be responsible for building the REST API, while UVCon would serve as the development server during local testing. To ensure that every request and response followed a predictable format, I chose Pydantic for data validation. Since the core functionality depends on Google's Gemini model, I also installed the official Google Gen AI SDK to communicate with the API. Finally, I added python.v so that sensitive configuration values like API keys could be stored securely outside the source code. Choosing the right dependencies early helps establish a solid foundation for the project and reduces unnecessary complexity later. Once all the packages were installed successfully, I generated a requirements file so the entire backend environment could be recreated easily on any machine. This small step makes the project easier to share, deploy, and maintain in the future. After installing the required packages, I created the application's entry point. In FastAPI, the main file is responsible for initializing the application and defining the API endpoints that clients will eventually communicate with. At this stage, I wasn't focused on implementing the complete business logic. My goal was simply to verify that the server could start successfully and respond to incoming requests. Beginning with a minimal application allows me to confirm that the development environment is working before introducing additional complexity. This incremental approach makes debugging significantly easier because every new feature is built on top of a stable foundation. Once the application was running correctly, I knew the backend was ready for the next stage, which involved integrating the Gemini service and preparing the API to handle prompt analysis requests. Since the application communicates with the Gemini API, it requires an API key for authentication. Instead of placing that key directly inside the source code, I stored it in a separate environment file. Keeping sensitive credentials outside the application is a standard software development practice because it improves security and prevents accidental exposure when the project is shared or pushed to GitHub. This approach also makes configuration much easier across different environments. With the backend foundation ready, it was finally time to implement the core feature of the project, communicating with Gemini AI. Instead of placing all the AI-related logic directly inside the API endpoint, I created a dedicated service file. Separating business logic from request handling keeps the application much cleaner and makes it much easier to maintain as the project grows. If I decide to switch AI providers or add more functionality in the future, most of those changes can be made inside the service layer without affecting the rest of the application. Before writing the integration, I thought about the kind of response the frontend would eventually need. Returning a block of plain text would make it difficult to display information consistently, so I designed the service around structured output instead. The goal was for Gemini to eventually return information that could be displayed in dedicated sections such as scores, detected issues, improvement suggestions, and an optimized version of the user's prompt. Even though the front end wasn't connected yet, planning the response format early would save a lot of work later. The next step was creating the prompt that would be sent to Gemini. Prompt design is one of the most important parts of building AI-powered applications. A vague instruction usually produces inconsistent responses, while a carefully designed prompt makes the model much more reliable. Instead of asking Gemini to simply improve a prompt, I planned the interaction so the model would analyze different aspects of prompt quality and respond in a predictable structure. This approach transforms the AI from a simple text generator into a component that behaves much more like an application service. Once the service structure was ready, I updated the main application so it could communicate with the Gemini service whenever the endpoint was called. Rather than keeping everything inside a single file, each component now had a clear responsibility. The API endpoint receives the request, the service processes the AI interaction, and the response is returned back to the client. Organizing the application this way keeps the code base easier to understand and makes future development much more manageable. At this stage, I intentionally kept the endpoint simple. Instead of accepting user input immediately, I focused on making sure the overall communication flow worked correctly. When building software, I prefer validating one layer at a time instead of implementing everything simultaneously. Breaking development into smaller milestones reduces complexity and makes debugging much easier because each component can be tested independently. With the integration completed, it was time to start the Fast API development server and verify that the application was running correctly. Successfully starting the server confirmed that the project structure, dependencies, and application configuration were all working together without errors. Reaching this point is an important milestone because it means the backend is ready to begin serving API requests. Fast API automatically generates interactive API documentation, which makes testing endpoints extremely convenient during development. Instead of writing temporary front-end code, I opened the Swagger interface and tested the endpoint directly. This allowed me to verify that requests were reaching the backend successfully and that the API responded exactly as expected. Tools like this significantly speed up development because they provide immediate feedback after every change. For this first version of the endpoint, I deliberately returned default values instead of processing real prompts. The objective wasn't to complete the entire feature in a single step. Instead, I wanted to confirm that the request lifecycle was working correctly before introducing additional logic. Establishing confidence in the backend first creates a much stronger foundation for the remaining development stages. This incremental approach has become one of the most valuable habits I've adopted while building software. Rather than trying to implement every feature at once, I focus on validating one milestone before moving to the next. It may seem slower initially, but it dramatically reduces the amount of time spent debugging later because problems can be isolated much more easily. By the end of this stage, the backend was successfully running. The project structure was in place. The Gemini service had been integrated into the application architecture, and the API endpoint was responding correctly. Although the endpoint was still returning placeholder data, this confirmed that the foundation of the application was solid and ready for the next phase of development. In the next part of this series, we'll replace these temporary responses with real prompt analysis from Gemini, implement structured JSON parsing and validation, connect the backend to the Next.js frontend, and complete the AI prompt optimizer from end to end. Another advantage of validating the backend before building the frontend is that it separates infrastructure problems from user interface issues. Once the API behaves exactly as expected, connecting the frontend becomes much more straightforward because the foundation has already been verified independently. We've successfully built the backend foundation for our AI prompt optimizer. In part 2, we'll connect Gemini with real user prompts, build the complete Next.js frontend, and finish the application from start to deployment. If you found this video helpful, subscribe to AI Builder Lab, and I'll see you in the next part.